So I want to introduce Kyle Kwaiser from the Institute for Social Research, the data manager. He does, among other things, he coordinates the release of data on a large study of mental health among U.S. military personnel. Some reasons about the structure of data?
Yes. Okay, so hi everybody. This is actually more people than I expected, which is great. So I've been asked to come here and talk about questions such as what is good data structure, what components of data are important, and what can go wrong. And I'll just give you a little bit more background about myself. I have a background in environmental sciences and environmental informatics, and I've picked up the data-related aspects on the job. First as the information manager for the University of Michigan Biological Station, where I was kind of a one-man show, and then secondarily in the Survey Research Center at ISR with a large team of data managers. So I'm coming from a very practical perspective, so I'm prefacing this because I know there are a lot of SI students in the audience, so feel free to either correct me or add other information as you see fit. But just to be clear, I'm not really coming from an academic perspective here, rather more of an applied perspective. And because of what I've done so far in my career is manage data, I'm coming from this from a data management perspective. Okay, so let's hop in. Okay, so first of all, for me, when we're talking about data, it's important for me to get some definitions out there. And I want to start with what is a data set? A data set. So Wikipedia would tell you it's a collection of data. Okay, and then these are what I think of as data. Representations of some observable phenomenon, right? Except you're missing quite a bit there because you don't know what the phenomenon is, you don't know what the data represent, and you're missing a lot of context. So these are data for me. A data set is more than just the data. It's also the metadata, the information you need to actually understand what those representation of facts include. Okay, just an aside, as far as talking about data, I usually use it as a plural. So these data are confusing me. I don't understand these data. And while I was at the University of Michigan Biological Station, that was relatively consistent. Now I come over to ISR, an organization I see as very front and center in the world of data, and I see a lot of mixed usage of that word. So I won't claim to have that my practice is best in that sense. So in terms of what types of data you might run into, I think there are a lot of different ways you can break down data, a lot, different classifications, some of which get kind of confusing and are difficult to remember. So this is kind of what I use rubric. And quantitative data and categorical data are primarily what I'm going to be discussing today. I think that's more relevant to the organizations that are participating in this. And it's kind of the data that I've worked with the most, although I have played with geospatial data, remote sensing data, that kind of information quite a bit, even less so with audio and visual data. So in quantitative data, this is kind of numerical data for me. And I see it as we've got counts. You go out or you have something that you're measuring and you've got a count of how many times that phenomenon occurred. You've got date time, which is also a measurement of something moving linearly. Date time data for me is usually a hassle. You open it up in the wrong. Each software platform has their own definition of when time started. You open up a data file that's got time formatted in one way, can get reformatted when you open it up into a different program. It's largely a frustration for me, but it's important. And then what I'm calling continuous, I don't really like that word. I try to think of some other type of word, but for me, this is something that you measure with a sensor, or where you have accuracy and precision going along with it, and you have units that you need to keep track of, and calibrations, maybe stuff like that. Categorical, in terms of what it would look like in your data file, it's going to be a string of characters, typically, and it can be either these data can be ordered in terms of you like something, you don't like something. in such a way that you could apply some kind of coding system. It would make sense to have 1 through 5, for example, or unordered. So then you're looking at it's kind of harder to quantify in the in terms of metadata, so metadata are descriptive information about the data that you're working with. You know, meta being kind of inward looking. Now, these are important, but the level of detail that you need really isn't well defined. It kind of depends on your purpose in using the data themselves. Typically, I think what you really need to have is in your metadata is an overview of the data set. It allows someone to pick it up and kind of understand the scope of it, what it's attempting to do, what it's attempting to quantify, and definitions of the variables. Okay, the variables, of course, being the header. If you think about the header row in your data set, you know, what is the definition of each variable? What kind of units are associated with it? And you know, if it's categorical, you may need to define better some of those categories. Some categories don't stand on their own. So if you just have a very restricted use maybe, and you don't plan for a long lifetime for that data set, maybe that's all you need. But if you have a longer view, or you know, for academic purposes, if you know, you could foresee someone calling you up in 5 years to ask you about this publication and the data that underlie it, well then you may need to add in more information. Or if you foresee yourself as this being a long-term data set that you're going to add on and add on. And I think that applies quite well to some of the organizations participating in the data dive. You might include an overview, you know, what's the overall purpose, how are the methods in terms of how you collected the data, personnel, who is involved in the data collection, who is involved in the data organization or quality control, who is the person you can go to with questions. That stuff is really handy. And of course, you know, any data set that you're going to have is going to require some sort of handling along the way. You know, if you're getting something ready for analysis, you're no doubt making changes to it. Probably a good idea, maybe necessary in some instances, to track those changes. And that kind of gets into you know, where you get into having raw data or kind of processed data. You know, the data can go through multiple stages, and that last one is how you kind of track those stages. Okay, so which is more important, metadata or data? Does anyone want to share an opinion?
I think it depends on your perspective. I mean, you can't know anything about the data, but you need to know about quality data.
Right. So yeah, they're interdependent, that's for sure. And I work primarily with metadata, so you'd think I would be biased toward making that argument that they are kind of equivalent in importance. But for me, the truth is that no one really pays you to go out and collect metadata. Right? They want the data, and they want to be able to understand them. There's usually very few specifications on what the metadata will look like. Maybe they're done at the last minute, you know, as the budget allows, stuff like that. So this got a smattering of other thoughts here, which is kind of ironic though, because what I've worked with, the metadata typically seem to be more complex. If you want to handle them appropriately, say put them into a relational database, you know, the amount of work it's going to take is probably more than it will take to get your data into that same database. You know, there are a lot more categories, and overall it can require quite a bit of effort. On the collection side, though, data may make up for that because they take a lot of effort to collect. Now, this idea of a data set for me is, you know, it's not just a single data file. You know, you can think of it as an attempt to address some kind of question. You've got these values that you're using to address some kind of question. And there's no rule that says there can only be one file or one table per data set. You know, it may take multiple different data sets and pieces from each of them in order to really answer a question. And then you can get into this, you know, this multiplicity, I guess. For me, you know, the way your data set will look and the effort that you're going to put into it is kind of dependent on what you're going to use it for. So if you're just using it if you're using it immediate for analysis and you don't need to keep it around, then you just need to do enough to get it to that analysis point, and you got your job done. If you're looking to archive it and do analysis, then typically maybe your archiving data set's a lot broader in scope, and you split that into separate data sets, smaller data sets, data files, to facilitate your analysis. What do we got here? So another thing, I guess, that for me that will bring in the need for multiple data files is when you have differences in your sample frequency. So usually in a data file, you're looking at every row as another observation. That's kind of the typical, you've got your variables on the top header line, and then every new row is, it's another person checked out a book, another grant was distributed, another member joined, something like that. But often you can have different resolutions in terms of your time frames and different data sets. So, maybe, to become an example on the top of my head, maybe you're looking at how often people are checking out different materials from the library. But then you have another data set that aggregates at a monthly level, how many total number of times those materials were checked out. Okay, so in that sense, you want those probably as separate data files, preserving the higher resolution of your daily reports, but allowing you to aggregate that information and combine them for analysis later on. Okay, that's where you get into multiple data. So you might actually create like a third data set that's a combination of the two. In terms of, we'll get more into formatting, but in general, tall and skinny is the preferred format for a data set. So if you can figure out ways to have a column contain multiple different values instead of having multiple columns that cover the same information, your data set gets longer and that doesn't have as many columns. It's usually the format you're going to want. Now, having said that, some statistical programs, especially specific ones, may ask or may demand that you use an alternate format. And that's where you get into the purpose, what your goal is in working with the data. And I've been over at a workshop over at Rackham on survey design and methodology, and the speaker there mentioned that all data have errors. That's probably an important attribute to keep in mind. I think we'll talk about that more in a second. Okay, so storing data in metadata. I've got three just kind of general ways that I've seen it and done it. One being in a simple text file. So these are formats of a TXT format, CSV, which is comma separated values, where you have a comma essentially between every column, or .dat. These are just files that give you less functionality in terms of, you've probably seen the error, or the warning. If you do a lot of work in Excel, then you go to save it to a text file, it gives you this warning. You're about to lose information. We can only save this one sheet or something like that. So it's got less features associated with it, but the nice thing is that it's a more persistent format in terms of it's more, works well across different platforms, operating systems. Probably we'll be able to read it just as well now as in 10 years, assuming you got it on a medium, a disk or a hard drive or something that's not going to become obsolete. And this is just an example of some atmospheric data from my days working at the biological station, where we've just got metadata plunked in the top of the text file, very sparse, but gives you probably enough to work with the data, assuming you trust the people. And then these would be tab delimited columns. So this is something that it's simple, it's easy to implement, but it's also persistent. And with the contact information there, assuming they remember what they did, you could usually locate more metadata if needed. Okay, you can also use proprietary formats. This would be like your Excel files, your SAS files. The IBW it's for its software called Igor Pro, used by atmospheric scientists. That brings up the point that one of the issues you get into here is if someone else has to come and pick these up, they may not, you can't just assume they're going to recognize what program to use to open the thing. And you're going to give them a headache even just trying to get it open, and they may not be able to. They may have to pay for an expensive license if they do get it open. These formats can also go out of date, but the nice thing about them is they typically give you more features and more power and more compatibility with your analytical programs. Let's see, another option, sorting your database tables. In a lot of ways, the format of your data won't really change a whole lot doing this. You just set your rows and columns and you just plunk it into a database instead of a text file. That doesn't affect it a whole lot. It does give you more control and quality control over what happens to them. So if you have a data set that's updating frequently and needing to be opened frequently, this allows you to, if you're just in a text file, there's a possibility you're going to screw something up while messing around in it. It's a little bit harder to do that when things are in a database table. Of course, there are higher technical thresholds needed in order to migrate everything into that structure. And these are just two examples on the bottom. When I was at the biological station, the focus there was really on our data management system was on preserving the metadata, partially because the emphasis needed to be on the researcher and kind of making things, giving them proper due. So these are all kind of different facets of that metadata, who it was, what the project was, the data set, name, different files associated with that data set, and then variable information. Now I'm at the Institute for Social Research, and this is how we store our metadata. I won't go into it in detail, but essentially the information kept here focuses just on the data set, the data file, and the variable. So the emphasis is different given different organizations and different meaning, different, purposes. Okay, so I saw a few points where sensitive data were brought up in terms of, a concern. And I won't go too much into this, but I did work while I was in the College of Literature, Science, and Arts in terms of defining sensitive data categories for the college and trying to get faculty to identify what their, in what ways their research was sensitive. Most of these won't be relevant to our nonprofits here, or community organizations, except this personal private information, which is personal private information, PPI, also called PII, personally identifiable information, which is information about someone who allows you to identify who they are. But there are it's good to know that there are a lot of other different types of sensitive data. Some of them involve federal laws, some are maybe just kind of embarrassing if the sensitive data are compromised, but good to know. In terms of protecting, removing or desensitive, making your data less sensitive, I've kind of seen one breakdown that I like which is between de-identifying data and anonymizing data. So if you're de-identifying something, you're mostly obscuring that connection to who that person is, versus if you're anonymizing, you're completely breaking the ability of anyone to identify who personally is part of your data set. And for me, disclosure analysis is the process of ensuring that you've appropriately anonymized something. It's more than just it's more than just pulling out the name and the address and other information like that, because there could be possible to be other information in there that will allow someone to reestablish who that person was. So bad examples, if I've got library records and for the same person, I've got an identifier in there that lets me know what this person checked out over a couple of years. Maybe they frequented a particular type of religious text, maybe giving me some idea of what religion they were. Maybe at some point, some kind of medical texts or something, or books about pregnancy. So then, maybe I can infer the religion and when this person, maybe she's female, maybe she got pregnant at some point. You can kind of work back from some of these data to who a person is, and you want to kind of go through that thought process and either remove those variables or aggregate them. So instead of having individuals, have groups, collapse information so that you have multiple counts of, this book was checked out 20 times over the last, 3 years or something like that, rather than when it was actually checked out. There's also top coding and bottom coding. So that would be in the case of, that would be collapsing. If you have a categorical variable, that would be collapsing some of those categories in order to increase your frequencies. So instead of having, if you're at the Y and you have how many children does a family member have, and the number's 12, there probably aren't too many people that go there that have 12 kids, so you could pretty easily identify who that person was. But if you have if you alter that category to read 4 and up, 5 and up, and you can decide on how you want to categorize that, how you want to top code it in this case, based on the frequency of those numbers. So you probably don't need to bottom code in that case. You probably don't need to combine 1 kid and 2 kids, right? Because it's a fairly frequent number of children. There's just a little bit of the source. I also thought it was good to talk about because I actually have a library card and I go to the Y, so you guys have records on me. Other concerns with sensitive data, don't email it. If it's really sensitive, don't print it. Or if you're going to print it, lock it up when you're not using it. Email isn't very secure overall. Control who has access to it. Encrypt it. So encryption is kind of maybe technically challenging, but there are some services that you can use where the encryption is actually part of, it's part of using that service. So this example is box.com. If you upload something to box.com, so if you need to distribute something, you can potentially upload it to box.com, and then it's encrypted while it's being uploaded, and it's encrypted when it's sitting there. Okay, so you're using a cloud service that maybe you've got less trust because your IT group isn't administering it. It's actually, I think, quite secure. Then you can release that data using a link and a strong password. So that would be a good alternate to maybe emailing the files. This probably isn't fully relevant to the groups we're working with here, but there is a resource on the university page which goes through these different sensitive data types and identifies resources that you can use those different types of sensitive data on. So that might be a reference if you want to take a look in terms of where to get an idea of what you can do with sensitive data and what you shouldn't do. So this is just kind of a quick one, but in terms of quality control and quality assurance, so for me, quality assurance is something you do before the data are collected. You're testing out a functionality. It's evaluating things before you start actually collecting data and trying to avoid problems. Whereas quality control is kind of the post-processing that you're going to do, maybe as you're getting your data set ready for analysis, or someone brings attention something very erroneous that happened. For me, I see 2 kind of major types of errors: systematic and random. So systematic, maybe at a library, is someone always grabs the wrong barcodes and is attaching them to different media, right? Whereas random is, maybe just periodically the piece of media gets in the wrong pile and it then gets the wrong barcode or something. Maybe not. For me, the random errors aren't as critical because when you're doing your analysis, what I see it as, you can still get to the same results. You just increased your variance a little bit. So you need a little bit bigger sample size, or you need a little bit more ancillary data in order to get there. Whereas systematic errors could potentially lead you to the wrong conclusions. Ways to run quality control. I should really have more here because I'm currently quality controlling metadata for this Army STARS project, this mental health project. And new problems just keep coming up. But you just find them in the course of working with your data enough. One thing you can do, though, is logic checks. If this person if maybe you're only giving funding to a group, you got a rule, we can only give funding to this group or any group once every 2 years or something. If you start seeing violations of that rule, then either you have a problem in how you distribute your money, which I would hope not, but maybe it's more just a recording error or something that popped up. Then you can go back and often you can fix it using these other records to check against. Let's see. And if you can't fix it, if you can identify it, that's still progress because you can typically just drop it before you do any analysis. No idea. All right, so that's all I have, but I think that probably about good timing. So I think we can go into questions. Yes.
And what are the slides you had talking about like tall and skinny data is preferred, and just wanted to
Right. So I've got an environmental sciences background, so I'm going to have to use examples from my field. So say you go out and you want to count species in an area. Instead of having species A, species B, species C, species D, all the way across the top, which you might want for some analysis software. There is software that will demand that if you want to get like a diversity index. You just have a species category, and then you have those species going down in different rows. So essentially it could end up repeating a little bit, but it gives you a skinnier data set, but that's longer. From a documentation standpoint, for me, that's easier because you've got fewer variables to define. And typically, I think that's, for archiving, that's how you would want it. Maybe not all the time for analysis, but for me, it's a lot easier to go from skinny to wide if I need to than back. But that would be a really good way to do it. Yeah, I mean, what you really want to identify are low frequencies. So, if you have if you've got information about, I guess I'll just go with families again. If you want to look at how many families have one kid, how many have 2 kids, or if you have, types of media at a library that aren't checked out very often. Looking at the histograms will give you a good idea of what that does. Thanks.